Hello students, welcome again for today's video class. In the last video class we have started our revision work for final term. So continuing that process, today I will continue the revision of chapter number 4 that we have already started in our last video class. So we have seen up to the ions and the radicals. So today we will see the representation of compound. As you know, the elements are represented by their symbol and molecular formula, but how can we represent the compounds? Compounds can be represented by chemical formula, you know. So we will see today how to make a form a chemical formula. As I have already told you to remember all the symbols of elements and their valencies. So these are the two important things that we need to frame a chemical equation. Elements, their valencies, and the radicals and their valencies with their symbols. So today we will see how to frame a chemical equation. First of all, we will see about ferric carbonate. Okay. So first of all, the formula of we will see that is iron 3 carbonate, that is ferric carbonate, is a polyatomic ion. So here is iron is there, and obviously carbonate is there. So first of all, we will see the ferric carbonate. See how we have to make a chemical formula. So in this way we will see ferric carbonate. So one is element is there and one is radicals. For first of all, ferric is Fe and carbonate is CO3. Now we have to write the valency also. Ferric, that is for that we have to write it is 3 plus and it is 2 minus. So when we do the crisscross, so what we will get? Fe2 CO3 whole 3. Fe2 CO3 whole 3 is the formula of this compound, ferric carbonate. In this way we have to frame the formula. So another examples you can also take. Suppose if you take ammonium carbonate, ammonium carbonate. Okay, so again we have to write the ammonium is NH4 and carbonate is CO3. So now we have to write the valency of both. You know the valency of ammonia is 1 plus and carbonate is 2 minus. So when you write the chemical formula, what you will get by doing the crisscross, NH4 whole 2 and CO3. Ultimately you will get the formula NH4 whole 2 CO3. This is the formula of ammonium carbonate. The similar way we can make another formulas also. For that you have to remember all the radicals, they are with their valency. So if you remember, by this way you can easily frame the chemical formula. Now another important thing that is here in your chapter here, that is the significance of valency. As you know, the valency, you know, the combining capacity of an element is called a valency. So it has so many significance. What significance is it have? It can be the number of hydrogen atom that can be combined with one atom of an element to form a compound with hydrogen. So number of charge that is a radical carries, that any radical that carries a charge is same as that is its valency. So that means if a carbonate is having 2 negative charges, that means these 2 negative charges will combine with the 3 positive charge of the iron to become stable and form a chemical formula. So it is very valency have the significance in the derivation of chemical formula of a compound also. So valency based on hydrogen atom. What is we mean that? Valency of element and radical can be derived from a chemical formula of a compound. This is especially true for the element and radical that combine with hydrogen to form a compound. So hydrogen is a common element that by comparing with that we all do the things. For such a compound, valence of an element or a radical is given by number of hydrogen atoms that combined one atom of element to form a compound. For example, if one atom of hydrogen combined with one atom of chlorine, it will give HCl. If one atom of hydrogen combined with NO3 to form nitric acid, that is HNO3. So in this way we can see the radical of NO3 is also -1, where hydrogen is also -1. So we have the we can also find out the name of the chemical elements or radicals present in a compound, and also we can derive the valency from a chemical formula. So next is the periodic table. As you know, we have all 118 elements with us. So it's very much tough to remember this name of the element in a systematic way. So to remember the elements in systematic way, we have the modern periodic table. In this periodic table, as you know, it has 7 horizontal rows, that is called periods, and 18 vertical columns that are called groups. So elements, when we do the electronic configuration of the atomic number of any element, we can also find the number of groups and period of the corresponding elements. Okay, so these are the important things that we have to remember in this chapter. So I hope we have completed this chapter, the revision also. Now you go through it and have a good preparation for your final exam, and please ask me your doubts in your online classes. It's very important chapter. This chapter is you have to remember these things till you will study chemistry in your future classes also. So is very important that atomic structure. In the next class, in 8 also we'll study about atomic structure in more details. So students, I hope we have got the revision of this chapter. In the next class we will start the revision of another chapter. So till then, goodbye. Thank you very much for watching this video. Thank you very much. Stay safe, stay healthy. Thank you.